Hello, good evening 821. This is your physics teacher, Mr. Matt, speaking. I'm going to go through workbook 2 with you in a series of videos to help you with your distance learning for the rest of this quarter, or as long as needs be. Maybe not the whole quarter, let's see. So to find your workbook 2, go to student share, your shared folder, right, on Google Drive, and just go to physics, quarter 1, cube 1, and we finished workbook 1. Now you need to do workbook 2. Some students I messaged in the group, you have not done workbook 1. So you've scored 0 for this unless you send this to me soon. Make sure it should have been done a long time ago. But you were absent in week 3. So you did not complete the assessment for workbook 1. If you have not done this, please upload to the Google Classroom, complete that assessment and upload it to the Google Classroom very soon. Now, a focus for this is workbook 2. Let's open it and we'll just download it because you want to write on it, and you could open it in Notability on your iPads if you have them. If you don't have anything like this, you're on the laptop like me, you can just download it and then open it in another online software. You don't have to have anything special for that. It's up to you. If you want to use Notability, it's better, I think, if you can. But for me, I don't have any Notability. I don't have iPads or Apple things. So I just go to something called, just go into your browser, Google. I'm going to just type in PDF, ESCAPE, pdfescape.com. Now this website allows you to write on the PDF. You don't have to download anything, go to the free one. Upload PDF, and then it's saved down here. You can find it in your file and put it in, or you can choose the file. I know it's here, so I'm just going to drag it in. Now just check it's the right one. Looks like it. Mass, weight, level 2, quarter 1, workbook 2, weeks 4, 5 and 6. So this video will take us through the learning in the workbook for week 4. There's another video will come soon for week 5, and then these videos should help you to solve the problems and to learn from home. Safe learning is good learning. So as always, make sure you fill in the top with whatever your A number is. You can change the font size here. Yeah, let's make that whatever your number is. Your name here, whatever your name is. Your class, we are 821, and your teacher. Some of you, your attendance is very bad, probably you don't even know my name. Mr. Matt is the physics teacher. For you, this quarter, this is, I think, your first time doing physics. So let's have a look at what we're doing these couple of weeks. We're going to look at some keywords: mass, weight, volume, and density. We're going to calculate them, we're going to understand them, and let's get started. Alright, freehand mode, just sign and date. It's date today. You also need to know what the definitions, so what does the word mean. The keywords are always at the top of the workbook for that workbook, and it's in Arabic too, so you know what mass is now. You know what weight is, you know what volume is, you know what density is. So we won't talk about them now, but they're good to remind yourself if you forget. Just check up to the top of the workbook, and it really tells you what these things are that we are talking about for the next 2-3 weeks in physics class. Alright, let's get stuck in straight away. We're in week 4. This is lesson 13 and 14. I'll cover 4 lessons in this video. So let's go for the first question. What is your weight? Is your answer correct? Okay. What is your weight? Well, give yourself a chance to think about it. Some of you might say, I don't know, 80 kg. 80 kilogram. My weight, 80 kilogram. But actually that's the wrong answer. It's not correct. So we delete this. This is not your weight, this is your mass. Mass is measured in kilograms, and weight is measured in newtons, so it's a force. To find your weight, you need to take your mass and multiply it by gravity. There's an equation there. Weight equals mass times gravity. So let's go to PowerPoint now explaining all of this. Let's start with this idea of force. Now force is like a push or a pull, right? You can have friction pulling this back. If there's lots of friction, it will stop. You have drag forces. This is the air pushing against the plane. Simple push and pull force. These are all forces. Magnetic force, magnet force. And the one we will focus on today, which is weight force. The weight force is the force that pulls you back down to earth. Now you can see that we can't actually see force, so we just draw an arrow to show that it's there. We have to imagine force. We feel forces, but we don't really see them. Mass we can see. Mass is the actual stuff, the things that the universe is made of. Mass is the stuff things are made of. This is a simple definition. A better physics definition, you would say matter. It's the matter, the particles, and not just the amount, but the mass of each particle too. So, mass of a yoga ball. What is a yoga ball? Okay, good question. Here's my yoga ball. Imagine the yoga ball there, doing some exercise. And here's a water bomb. What is a water bomb, you ask? It's a balloon filled with water. Yeah, these ones. Now, which one has more mass? The yoga ball or one of these? Now this one is smaller, right? So it has less mass, right? No, not right. You can have things which are bigger and have less mass. This is the case here. Look at the amount of stuff. There's 1, 2, 3, 4, 5, 6, 7 particles in the yoga ball. Well, air has less stuff in it, less particles. It's more spread out. Whereas even though the water bomb is smaller, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maybe 20 particles in here. So there's more stuff in the water bomb. So it has more mass. Mass is the amount of atoms, not the amount of atoms, but the amount of stuff. We can say protons and neutrons and electrons if we are being specific. The amount of those three. Now, I'll give you an example of what I mean. Here's quite a big piece of paper, right? It's taking up a lot of space. Make it 3D. It's quite big, but it doesn't have any mass. It's very light, right? Now I can think of something which is very heavy, but it's actually quite small. Let's look at this speaker. The speaker is much smaller than the paper, but it's quite heavy. It's got a lot of stuff in here, so it has a bigger mass. This mass is maybe, I don't know, 500 grams. And this big piece of paper, it's maybe only I don't know, 5 grams, 2 grams, nothing. So that's mass. That's the idea of mass. So when you say which one has more mass, you say the water bomb because it's made of more particles. Now we already said this. Weight is not the same as mass. Weight is a force. It's like a push or a pull. Well, it's actually a pull, and it's pulling you down to earth. It's like that feeling when you jump. You can jump now and just feel weight pulling you down. Now this type of force is caused because there's this invisible field around Earth. Imagine these blue lines here. We call it gravity. Gravity is around all masses, but there's lots of gravity if it's a really big mass. And of course, Earth is the biggest mass on Earth. It's the mass. It's huge. So it has a really big gravity, and this field, we call it a field, a gravitational field. If there is a mass, m, there's the mass, inside the field, then that mass feels a force. It feels like it's being pulled. So the mass is the object itself, and the weight is the force pulling the mass towards actually the center of Earth. If there was no floor, if there was no sea, no land there, then the mass will just fly into the middle of Earth and then stop, because it's everything on Earth is being pulled towards the center. Okay, so this is the difference between mass and weight. One is the force and one is the kilograms, the amount of stuff. Right, they all link together. So if we take the mass and we multiply it, so mass verb the gravitational field strength, gravity, and we get the weight. We can find our weight. So next time someone asks, what is your weight? You can say, my mass is 80 kilograms. Times it by, I don't know what gravity is. Well, you do now, because I'm about to tell you. Gravity is just on Earth about 10. About 10. So you times your mass by 10, you'll find your weight. This works for any mass, not just you. You can find the mass, the weight of this water, the weight of anything. And we can make a triangle formula to help us solve problems. We'll maybe solve some problems later when we get to the maths. Remember, gravity is 10. Well, gravity can change as well. Won't go into detail now because it's not the focus of the lesson. There's less gravity on the moon. So look, there's less weight. Look at the size of the arrow, it's much smaller. Because with less field, with less gravity, it doesn't pull as much. This big planet, or not a planet, a moon, doesn't have as much mass to pull the other mass in. So if you stand on Earth, maybe your weight is 800 newtons. You have 800 weight. But if you stand on the moon, maybe your weight is only 200. It's much less, 150. But your mass doesn't change, right? You still have the same atoms on your body, same particles. So your mass stays the same, but if we have more gravity, we have more force, more pulling. Okay? Alright, well, we won't focus on this. Let's go back to the workbook now and solve some problems. Check out some more information. So here we are. What is your weight? Well, I just told you, you've got to do your mass, which maybe you told me it was 80 kilograms. And you've got to times it by 10, gravity, mass times gravity. So if you said your mass was 80 kilograms, your mass is actually 800. Now it can be better than 10. This is only an estimate, a rough number. The accurate number is 9.8. So if we say gravity is 9.8, always 9.8 on the surface of Earth. So 80 times 9.8 is 784. So your weight, if your mass is 80 kilogram, your weight is 784, and we say newtons. This is the unit for, like kg, kilogram for mass. We'd say newtons for force, or weight, force. Alright, well, we've got the equation there that we've already talked about. G for gravity, M for mass, and W for weight. And we've talked about those units as well, they're different. Sometimes we measure mass in grams, not kilograms. So 80 grams, that's very light. Maybe my wallet is 80 grams. So you're not going to weigh 80 grams. Let's go for kilograms. Remember, the kilo is times 1,000. 1,000 more, 1,000 times more. Now there's a few ways we can compare mass and weight, and that's the focus of today, to describe the difference between mass and weight. So you've already got a bit of an idea. There's lots of facts here that we can read in this table. So mass is a property of matter. Talked about particles, matter, and the mass of an object is the same everywhere. Remember, we looked at the Earth and the Moon. Well, you have the same mass on both planets. Now, weight is not the same. It depends on the gravity. I told you about this. We looked at the Moon and we said the weight was less on the Moon because there is less gravity, so they are linked. There is a relationship, we say, relationship between the two. Now, mass can never be zero. I don't know really why mass can't be zero. Technically in space there is nothing, so you could say mass could be zero. But I think what it means is the mass of an object cannot be zero, because an object is made of mass. So if something is made of something, like this coin, it must have some mass. Whereas you can have an object which has no weight. It sounds strange, but imagine we take the object out of the field, right? Let's get this mass and put it over here. Well, now there's no gravity, so there's no weight. The weight only happens because of the gravity, right? So if we're out in space, away from the planet far enough, there's no gravity there. So you just float around. That's why you don't get pulled when you're in space, because there's no weight, right? So masses can be, we say, weightless, with no weight. Mass is a scalar quantity. Okay, scalar just means there's no direction, right? So I wouldn't say I weigh 50 kilograms to the right or to the left or north or south. I don't have a direction for my mass. So this mass has no direction. It's a scalar. All units are either scalar, so don't have direction, or vectors. That means do have directions. Now, a direction is with an arrow. This is clear from the picture too. If I say my weight is 10 newtons, I should also really say my weight is whatever it was, 700, 800 newtons towards the center of Earth, because weight has a direction. It's an arrow, right? Always draw weight as an arrow. It has a direction. You can see here, look. All my weight, all my forces have direction. They're all vectors. Forces, vectors, they have direction. So that's an aside learning that we've done there. All units are the same, so length is a scalar because it has no direction. I don't say I'm 10 meters tall east or west or up or down or left or right. I'm just 1.7 meters. So all things are scalars or vectors. Mass is a scalar, weight is a vector. Mass may be measured using an ordinary balance. What do I mean by that? A balance is just, well, you can Google it. Wasn't very good. This is what in England we call scales. It's a balance. It measures mass. If you put something on it, you will use it for cooking maybe. Tells you how many grams of rice you have or something. Flour, eggs, butter. Make a cake. You measure the grams. Now, we don't use the same thing for measuring force. So use a balance to measure mass. Weight is measured using something else because it's a pulling force. We use something called a spring balance. Now, let me just show you what that looks like. A spring balance. I guess it has a spring, right? Usually these things are named logically. So we can see here what a spring balance looks like. It's like a hook. And if we want to measure the weight of something, we put it on the end of the hook and we see how much it is. A good example of this is if you want to weigh your bag when you go on a plane, you find the force of I'll just find mine and show you. Here it is. So it's the same thing. You just can't see inside, but inside there's actually just a spring in there. You can see from this picture. It's just a spring which gets pulled and it's related to the weight force. So it can tell you. Now, it can also tell you the mass this as well, but so you can use it to measure mass or weight. You get the idea. It's called a spring balance. We already talked about grams and kilograms for mass, and weight is measured in newtons because weight is a force. Famous scientist Isaac Newton, he kind of realized about this force was everywhere. So he named the unit after him. So if we want to say the amount of force, we wouldn't say 100 jelly beans. We would say 100 newtons. Just means we're talking about force. Alright, let's check out the task for today. So we just have to put whether it's if this is talking about mass, a fact about mass, or if it's a fact about weight. So it's the measure of the force of gravity. Well, it's a force. I'm going to say that one is weight. So I'll just put W for weight. So that's an example of what we have to do. A measure of the amount of matter. Remember, matter is the amount of stuff. It's like particles. What was the amount of stuff? I can't remember. Let's scroll back. Mass is a property of matter. So it's mass. Mass is the amount of matter. So I'll just write M here for mass. And you see, you do that with all of those. You can complete it. I won't do all of them with you. You can solve those yourself just by checking out the facts on your PDF. Okay, so what did I learn from these lessons? I think the first most clear one is you learn the difference between mass and weight. Maybe you learn something like mass is measured in kg or g, grams or kilograms. We learned that weight is not the same as mass. Maybe you learned that weight is a force. Measured in newtons. So just write a few things, a few key facts that you learned. You don't have to write everything here. This is just an example. You decide what you think you learned the best today in that little section. What did you enjoy? I don't know. Maybe you enjoyed working from home, studying from home. There we go. You can pause this at any time if you want to go through those notes again. If you have a phone and a laptop, you can watch on the phone and complete your notes on the laptop. It's your choice really how you do it. Let's go to the next 2 lessons, because 4 lessons a week and I will cover 1 video a week with you. to help you with your learning. It will always go on the shared folder, so just look there, and I will also upload it to the WhatsApp group if I'm having problems with the Google Drive. You can go there. Just bear in mind that they're quite big files, so don't just download them willy-nilly if you only have so much data and you're out. Mind you shouldn't be out, right? Everyone should be at home on the Wi-Fi. Alright, so what are these next 2 lessons? We're going to look at volume, this new word. So we've talked about mass and weight. Now we're going to look at volume. Now volume is just the amount of space something takes up. So how much space does it take up? Like the size. You can think about volume as the size of the object now. Alright. So the first pop quiz is exactly what we just talked about. I'm not going to do all 3 with you. Maybe we'll do the first one together. So 3 differences between mass and weight. The first one that comes into my head is the units. Mass is measured in kg, but, so to say, not the same, but weight is measured using newtons, right? N. I'll write the whole word, kilograms. Weight is measured using newtons. Alright, so think of 2 others. You don't even have to think of them if you can't remember, because look, they're all here. And they link up. We use different things to measure it. Use different units to measure it. Mass doesn't change on the moon, but weight does. Just pick 3 of those and write them in as your pop quiz starter. Okay, so what is the difference between volume? Now, this is a good one. I'm just going to take a piece of paper, 2 pieces of paper, right? So, 1 piece of paper, the full piece of paper, right? Full piece. So it has some mass, and it takes up some space in the air. Some of the, if the paper is there, in the air it cannot be there, right? You can't have both in the same place. It's taking up space. That's what volume is the space that the object takes up. Now this looks like it takes up a lot of space here, right? When I put it this way around, you can see actually it doesn't take up much space because it's so thin. It's very, very thin. So the space something takes up depends on something called its dimensions. The height, the width, and the length. The width is quite big on this. The length, the long side, is quite big. But the thickness, or the height, you could say, it's very, very small. So its volume is small. If I do this, what happened to the mass? Think about it for a second. If I do it even more. What happened to the mass? Nothing, right? It's still the same piece of paper. It's still made of the same amount of atoms. So the mass is the same. But the volume changed a little bit. It doesn't take up much space now. This object compared to, let's get another piece of paper, the same piece of paper, let's imagine. Let's fold it into a shape. Here we go. So here's a shape. They're the same mass because they are the same. They are the same paper. They're just one piece of paper. This one has less volume because I screwed it up into a small ball. So mass and volume are not the same. You get the point. Bigger usually means more volume. Alright then. We can be better than saying just bigger, because we want to know exactly how much, for example, water I have in my drink, and that they tell you, right? They tell you if it's 500 or 300, how much water, how much space the liquid takes up, the volume of the water. So we use maths and we can calculate. Some key words here. Just take you through a couple. The volume is related to the quantity, that means the amount of the substance present. So how much stuff is there in a given temperature or pressure? Okay, there's a lot of physics words there. I don't want to overcomplicate things. Certain level. Volume is always in 3D, three dimensions. So on this screen is 2 dimensions because there's no thickness to this letter on the screen. 3 dimensions must have a length, a width, and a height. 3D, like a cube. Alright, well, density is how much stuff there is in a given volume. So this, maybe we'll look at this at another lesson. I'm hoping we focus on volume today. I don't want to go into density, so let's see what the task is. Alright, so it is going into all of them. We're just doing the definitions though. Now luckily we've done 3 of them, so we can talk about density after we solve the others. Let's look at all of these together. It looks like we have to match. We're going to match the mass to the correct sentence definition. Well, we know what mass is. So let's read them all. The force of gravity on an object or substance. So the force. Which one was force from last lesson? Well, it was the weight, right? Remember, the weight was the force. We had a nice diagram of the arrow pulling you down. It was in the PowerPoint. The weight is a force. Well, these are forces. Wait for it. Is a force. Okay. The degree of compactness of a substance. Not really sure what that one is. I've not heard that word before. Compactness. I have. I'm just talking as if you are doing it, right? A quantity representing the amount of matter in a particle. Matter, the amount of matter, the amount of stuff. What was that from last lesson? The amount of stuff is the mass. How many atoms are there? How many electrons, protons, neutrons in an object? Great. So what about this one? The amount of space something takes up. The amount of space that is used was the volume, right? The bigger the size, the more space it takes up. So this is a small volume, the volume getting bigger and bigger and bigger and bigger. And as we blow up a balloon, for example, the volume increases. That's going to be volume. So we know the last one, density, the degree of compactness of a substance. So this is talking about how close together those particles are. If they're very close together, they'll be more dense. We can go back to our example of the yoga ball and the water bomb. Now, which one is the particles, these little dots, closer together? Which one is closer together? The particles. Yeah, it's the water bomb, right? The water bomb has got a liquid inside. Lots of particles close together in a liquid. The yoga ball has air inside. Well, air has low density, right? Because its particles are not close together. So we say the density is less. Here the particles are very close, so we can say the density is high. This is the idea of density. Usually, nearly always, liquids, water, oil, Coca-Cola has a higher density than any gas. That's why we can move through gas, because the particles are so far apart that you can go straight through the particles. Same with liquids actually, but the liquids we move through because of different reasons, not because of low density. Let's check out the PDF again. We've solved that task. Let's move on to task 3. We've understood those basic definitions, hopefully. Those 4 key words that seem to be the main focus for today, actually. That's a nice summary task, those 4 definitions. Remember, if you want to pause at any point on the PowerPoint slides for a bit longer, just to take in the difference between density, whatever. So task 3, let's read it together. How would you determine, so how would you find the volume? So we find the volume, how big something is. How would you find the volume of an irregular shaped object like a rock? Well, that's not easy. Describe it. Describe how you could find the volume of a rock. Now, if we want to find the volume of a regular shape, let's say this shape, we can just take this length here and times by, multiply this length and times by this length. So you've got three lengths, right? This one, and this one, and you multiply them all together. So this length, maybe 3 centimeter valve, 7 centimeter valve, 10 cm, and you'll find the volume, the space it takes up. There is a different equation for every shape. So when you don't have a normal shape like this, you have a strange shape. You can't really tell where is the three lines, the height, the width, and the length. It's not obvious. So take something like this. Well, it's not. You cannot use this method anymore. It's tricky. It's a different shape, so I can't say this is the length really, because there's nothing here, and it won't give me the right answer. So let's see how we would do that. My mouse will work. There we go. How would you determine the volume of an irregular shaped object? Now we can actually find the volume of liquids quite easily. because they take the shape of the container that they are in. So we could put this in a regular shaped container and find out how much volume there is here. Now if I put something in here, inside this water, do you think the water will go up or down? You think about it. Do you think the water level would go up or down if I put something inside here? Whilst you think about that, I will find something to put in it. Something I won't break. Okay, I've found something. My amazing selfie stick. Now I shouldn't do this over my laptop, but if I'm careful. Now my thumb is next to the line, so we can see what will happen to the water as I put this in. What is happening to the water? Can you see? As I take it out, the water goes down. As I put it in, the water level goes up a little bit. It's gone up by that small amount. Now that small amount, we could measure it, and that would be the volume that is underneath the water. So I could measure the volume of any shape if I put it underwater and I measure the difference in the height of the water. And you would have some kind of measuring on the side here if you had a proper measuring jug or measuring cylinder. So you need to describe that in your own words here. I'll start, maybe I'll have leave some blanks for you to finish. So we can put, let's imagine it's a rock now, not selfie stick. We can put the rock into, well, what did I put it in? You fill in the blanks. We measure the, what do we measure? Something of the water before and after. The rock is inside the water. So you could say height, I suppose, but really the key word for the lesson, what we're trying to define, goes here. Alright? Begins with V. So we can put the rock into we measure the something of the water before and after the rock is inside. So we measure it here and then we measure it here. Now there will be some lines on the side to tell you that volume. And the difference between those two, the difference in the height, that amount of water is the volume of the rock. So the difference in the, again, is that keyword. You spell it, find it in the text, make sure you spell it right, is the difference in the something of the water is the volume of the, okay, but what are we finding? Of the what? Finding the volume of the, what's the object? You finish the sentence. That's it. Alright, good job everyone. I hope that was helpful. you finish the sentences, finish the words there, give you the first letter of each word. You can always rewind the video and check what I said when I described the method. So what did I learn today? I probably learned what volume is. And I can say it is the space that an object takes up. Simply put, what's volume measured in? We didn't really talk about that, but we probably will. We can't really say we learned that. We learned density as well. We learned that density is a measure of how close the particles are together. So how close are they in an object? So we might have some materials will have a very light density. You can think of, let's go for polystyrene. You know, this is like a really light material, made of lots of little white bubbles. So the density of this is very, very, very small, very low density. The particles are spaced out. There's a lot of air inside. Let's think of a very, very high density. I could just write high density material. Just see what Google Images shows. It's showing some metal here, I think. Here's a nice picture to show the difference. Metal usually has a high density. That's why it feels heavy, because higher density usually leads to higher mass. So high density, the particles are squashed close together. The low density, they are more spaced out. There's a bigger gap between them. There's the link between mass, volume and density will be made clear, I think, in the next lessons. For now, let's finish that. I think I'm happy. I've said a couple of learning objectives. What did you enjoy about that lesson? Maybe it was interesting for you to answer the question, what will happen to the water in that demonstration. Okay, that's all for this week. So you can see now we're on week 5, which we've nearly started already. I'll make a video for week 5 soon. It will go onto the shared folder just like this video, and you guys will be able to learn and complete whatever it says on your distance learning objectives. Now I'll just show you where those distance learning objectives are if you can't find them still. Let's go to the drive. Let's go back to the drive. So it'll be in your drive folder. It's not showing it now. Anyway guys, work through those workbook activities and you should be ready and fine for assessment 2. Again, reminder for those who have not done assessment 1, that needs to be done ASAP, otherwise you'll get a grade of 0. Thank you, and remember, if you have any questions, any problems, just message me on the group, or if you would like, message or call me privately. I am here to help. Stay safe, stay at home, stay learning. Stay distance learning. Ma salam, everybody. Good night.